Hello students. In the last video lecture, I was discussing about the instruction set of 8085 microprocessor. So in this video lecture also, I'll continue with the same topic. So the next instruction that I'm going to discuss is SHLD address. SHLD address. So what is the purpose of this instruction? What does this instruction do? For example, SHLD, suppose any address I'm taking like C050H. So this instruction, suppose let the content of H and L be, let the content of H is 20H and the content of L is 40H. Now, as I have already told you, the memory that is associated with 8085 microprocessor, this memory has many memory locations and each memory location will store 1 byte of data and the address of that memory location is of 16 bits. Now, this is we know. Now, what SHLD C050 instruction will do? Suppose this is, I'm assuming that the content of H is 20H and the content of L is 40H at the time of execution of this instruction. Now, what will happen after the execution of this instruction? The content of L will get stored in the memory location which is mentioned in the instruction. Suppose here C050H is the address that is mentioned in the instruction. So the content of L will get stored in the address, in the memory location with the address C050H. And the content of H will get stored in the memory location with the address next to this address. Again, I am repeating, what does this instruction will do? This instruction will store the content of L register which is present in the microprocessor. It will store the content of L register in the address that is mentioned in the instruction, and the content of H register will get stored in that memory location which is just after this address. So this was all about SHLD instruction. Now since we were discussing about data transfer group, since SHLD instruction fall under the data transfer group instructions, so the flags affected will be none. Again, as I have told you, in data transfer group instructions, what happens? The data gets transferred or gets copied from a source to the destination. Here also the data is being copied from HL register pair to the memory location. So since this is just data transfer or data copy instructions, so no flags will get affected. Or you can say, since there is no arithmetic or logical operations taking place within the instructions, therefore no flags will get affected. So when I was discussing about the flags of 8085 microprocessor like sign flag, parity flag, carry flag, etc. So I told you that all these flags will get affected only when there is a arithmetic or logical operation. Only after arithmetic or logical operations these flags will get affected. And since the data transfer group instructions do not involve any arithmetic or logical operations, so the flags will not get affected because of these group instructions. Now, number of bytes, how many bytes instructions are this? So as I've told you, for example, SHLD is C050H. Suppose SHLD, let the address be C050H. So as I've told you, if every instruction of 8085 microprocessor is 1 byte for the opcode. Now if there is any hexadecimal number mentioned in the instruction, then depending on that the size of the instruction will vary. So as you can see, if this instruction has opcode and 16-bit hexadecimal 16-bit number. So this instruction will be of 3 bytes, 1 byte for opcode, 1 byte of the address, that is higher byte, and 1 byte, that is lower byte of the address. So this whole instruction is of 3 bytes. Now coming to the machine cycles, how many machine cycles are there? So as I've told you, SHLD address, what it does, what will happen if you give this instruction will get stored in the memory of the microprocessor, that is associated with the microprocessor. Now during the time of execution of this instruction, what microprocessor will do, it will fetch the opcode. Suppose SHLD, again I am taking the same example, SHLD C050H. So when you're giving this instruction to the microprocessor, this instruction will get stored in the memory. Like first the opcode of the instruction will get stored, then the lower byte, that is 50H of the address will get stored, and then higher byte of the address will get stored. Now during the execution of this instruction, what will happen? First microprocessor will fetch the opcode. This is microprocessor. What will happen? First microprocessor will fetch the opcode from the memory. So what is happening? First machine cycle, that is opcode fetch machine cycle, is taking place. So first opcode will be fetched by the microprocessor. So after fetching the opcode and decoding the opcode, microprocessor will get to know there is some address in which the content of HL register pair will get stored. So second machine cycle will be used for reading the lower byte of the address. Third machine cycle will be used for reading the higher byte of the address. So up to now, how many machine cycles? First was opcode fetch machine cycle. Second was memory read machine cycle. Again third was again memory read machine cycle. Now after getting the address, now microprocessor has fetched the whole address that was stored in the memory. So after getting the address, now microprocessor, what it will do, it will execute the instruction. How? That it will first store the content of L registered in the address. So fourth machine cycle will be used for storing the content of L into the address mentioned in the instruction. That is, fourth machine cycle is memory write machine cycle. And the last machine cycle will also be used for storing the content of H register in the address of the memory location which is next to the address mentioned in the instruction, that is C051H in this example. So all total 5 machine cycles will be used for the complete execution of this instruction. That is, first for opcode fetch, second for memory read, third is memory read, fourth is memory write, and fifth is memory write. So in this way the whole instruction SHLD will get executed. So how many T states? As I have told you, there are 5 machine cycles. Opcode fetch. So opcode fetch machine cycle needs 4 T states. I told you for the execution of this instruction, opcode fetch, then memory read, then memory read, then memory write, then memory write. All total 5 machine cycles it will need. This instruction will need for execution. So opcode fetch machine cycle has 4 T states, memory read machine cycle has 3 T states, memory read machine cycle has 3 T states, memory write machine cycle has 3 T states, and memory write machine cycle has 3 T states. So all total how many? 16. 16 T states will be required for this instruction. Now addressing mode, SHLD C050H or SHLD, whatever address that you want to write, whatever address you can write. So SHLD address. So this instruction is direct addressing mode. Why? Because here the operand, what is the operand? Operand is either you can say the content of HL register pair, or you can say the content of this address. So here the address of the operand, I told you while discussing the addressing modes that whichever instruction in which the operand's address is directly mentioned in the instruction, that type of instruction will have direct addressing mode. So here also you can see that the operand's address is directly mentioned in the instruction, so this type of instruction will fall under direct addressing mode. Now next addressing mode, here as I have told you what will happen in SHLD address, the content of HL register pair will get stored in the memory location. So the next instruction that I am going to discuss is LHLD address.